Hi guys. What you're looking at is a calendar for the 5 weeks that we will be out of school. I will upload this to Schoology to try and keep you organized with weekly assignments. What we're doing this week is we are going over the review sheet for probability. You were to have completed it before we came back to school, so I will go through each question, show you the work. I will also post this answer sheet to Schoology as well. And then your first assignment will be to complete the probability assessment that is very closely related to this review sheet. Number 1. It wants you to find the probability of A and B. The probability of A and B means to multiply the probability of A times the probability of B. So we are just simply going to multiply 0.7 times 0.31, which gives us 0.2325. Now, we do need to make one assumption in order to use this formula, and that is independence. We need to be sure the probability, or that A is independent of event B. Otherwise, we cannot use that formula. For number 2, the key word is OR. So the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. They give us outright each of these probabilities. Probability of A is 0.46, B is 0.68. Now for A and B, do not multiply those two numbers. They tell us in the question that the probability of A and B is 0.27, and that's what we use. When we put that in our calculator, we get 0.87. For number 3, it is a conditional formula. Probability of A given B is equal to the probability of A and B over the probability of B, the given part. They tell us the probability of A given B is 0.8. They also tell us the probability of A and B is 0.4. I'm going to change the probability of B just to an X. In order to solve for X, I multiply both sides by X to remove the denominator. I have 0.8X equals 0.4. Divide by 0.8, and X equals 0.5. Number 4, we have a two-way frequency table we are using. The key word in this question is OR again. We have the probability that the person is male or has never participated in a school sport. That is going to be equal to the probability of male plus the probability of never participated minus the probability of male and never participated. Now, probability needs to be less than 1, so it has to be a fraction. We find our denominator for each of these fractions by looking at where do we draw our line. Our verb is, so we're drawing the line there. Before that is what gives our denominator. Find the probability that a randomly selected person, there are 1,000 people we are choosing from, so that is our denominator. Probability of male, there are 660 males. There are 750 that did not participate in sports. That is the total from that row. And then there are 495 males who never participated. Put that all in our calculator and we get 915 over 1,000. For part B, probability that a student is, that's where we draw a line, female, given that she has participated in sports. That is going to be equal to females and participates over the probability that she participates, which is going to be There are 85 females that participated, and there are 250 that participated in total. Number 5, are these events mutually exclusive? No, because you can own both. If you could not own both, then it would be mutually exclusive. For part B, are they independent? We have to compare two probabilities. I am going to compare owning a cell phone and owning a car. I'm going to use the AND formula. So the probability of a phone times the probability of a car, is that equal to the probability that we have a phone and a car? They tell me the probability of owning a phone is 0.75. Probability of owning a cell phone, a car is 0.15. And they tell me the probability of owning both is 11.25%, which is 0.1125. When I multiply these two numbers, I get 0.1125. So they are equal, so they are independent. For number 6, there are 900 seniors enrolled in a school. They want the probability of a senior traveling to Disney or having Mickey Mouse luggage. So I'm going to do, the keyword is or. Probability of Disney or Mickey Mouse luggage is equal to the probability of Disney plus the probability of Mickey minus the probability of Disney and Mickey. So that is going to be 575 over 900 plus 125 over 900 minus 12 over 900, which comes to 688 over 900. Number 7, A says find the exact probability, meaning your answer must be a fraction. The key word in here again is or. Probability of A or B is equal to the probability of A plus probability of B minus probability of A and B. This time they tell me what the probability of or is, and I have to look for something different. Probability of A is 3 over 55. Probability of B is 5 over 7, and they want me to find the probability of A and B. I'm going to combine them. So I have 6 over 22 equals 62 over 77 minus the probability of A and B. When I move things to the other side, it comes out to be probability of A and B is equal to 41 over 77. Do not change that to a decimal. Part B says, are they independent? Well, I have to compare two probabilities again. So I'm going to compare the probability of A times the probability of B. Does that equal the probability of A and B, which I just found? So the probability of A is 3 over 55. Probability of B is 5 over 7. Is that equal to 41 over 77? If we change it to decimals, it's easier to compare. And we see that they are not equal, so they are not independent. On to number 8. This is a straight conditional one. We want the probability of NHS given they participate in a sport. That's going to be equal to the probability of NHS and a sport over the probability of a sport. They tell us the probability of both is 2.6%, which is 0.026 as a decimal. Use the number they give you. You don't multiply anything. Probability of a sport is 0.145. divide that, I get 0.1793. Now they want it to the nearest tenth of a percent. So move your decimal 2 places to the right, and I get 17.9%. Number 9. Probability that somebody has traveled to New York City, given that they have pink luggage, is equal to the probability of New York and pink over the probability of pink. They give us the given part. They want us to find the probability of pink. N and P is 0.18. I'll call this X. Multiply both sides by X to get rid of the denominator. So I have 0.45X equals 0.18. Divide by the 0.45. And X equals 0.4. Finally, number 10, we have a two-way table we are looking at. We want to know if liking snowmobiles and skateboards are independent of each other. I'm going to do a conditional probability, so I will do the probability of snowboards given skateboards. That is going to be the probability of snowmobiles and skateboards over the probability of skateboards, which is going to be, there are 80 that like both, there are 125 that like skateboards. I am going to compare that to the probability that we like snowmobiles. There are 105 people that like snowmobiles, there are 160 people total. Converted to a decimal, notice I went to at least 2 or 3 decimals, because if you round too soon, you can get the wrong answer. When I compare the 2 decimals, I see they are different, so they are not independent. If the decimals are not the same, they are not independent. Your first assessment will be a sheet on probability that will be very similar to this review sheet. If you have questions, you can text me, email me. We have a Google Meet set up for Thursday at 9:45. Have a great week, guys.